Good day, everyone. This is Diane Fodell. Thank you for joining the Cognitive Systems Institute Speaker Series. I'm happy to introduce Javier Busquets from Spain. Javier is a professor of the Department of Operations, Innovation, and Data Science at ASADA Business School. He teaches strategic management of innovation, technology, and digital business. He's the author of several international papers, book chapters, and journals. Javier holds a PhD in Management Sciences from Copenhagen Business School, an MBA from ASADA, and his Bachelor of Science from Universidad Politécnica de Catalunya. Javier has held executive roles in information technology and the telecommunication industry, where he served for 17 years. He has and continues to work with universities around the world on digital business, system theory, the strategy and governance of technology and innovation. Please help me welcome Javier, who will present today metaphors and algorithms as sources of knowledge. Thanks for being our presenter, Javier, and I'll turn the call over to you.
Okay, Diane, thank you very much. Thank you very much for the audience. I'm going to try to explain in the next 25 minutes why metaphors and algorithms are sources of knowledge, what are the differences, and what are the similarities in some ways. So I will try to I will organize my presentation into a brief introduction of what a metaphor is. Then I'm going to put two examples that explain the motivation of this talk, and then I'm going to conclude with, let me put it that way, a speculative or areas for thinking and for you to maybe react or add some comments. So let me start with the first part of this talk with the explanation of what a metaphor is. We normally consider a metaphor like a rhetoric component of our way of talking. Well, metaphors are for example, there is a quite famous metaphor coming from Machiavelli in the book The Prince, comparing a governor or a prince or people as lions or as foxes. So if we compare someone with a lion, we are comparing this person with strength and force. But lions don't see traps. Foxes, in contrast, they can see traps. So the recommendation of Machiavelli to the prince 500 years ago was, sometimes you need to show strength. Sometimes you need to be careful and look at the traps in front of you. Those are metaphors. Metaphors come from the imagination, but this imagination represents or explains some areas of reality that are known but compared with unknown aspects. So, for example, we know how lions and foxes behave, but by comparing this type of behavior with a person, we are highlighting or we are adding a relevance to a certain aspect of a person. Of course, metaphors cannot be taken literally because persons are not lions or foxes. This is absolutely something evident. But we are trying to emphasize or enhance some characteristics. This is the way metaphors works. Metaphors also are complete because they are trying to explain whole things by mixing some real components with others that aren't or are not so evident. But what is very important, and I think it's one of the most important aspects of a metaphor, is that it's based on experience. So that means that metaphors are based on empirical aspects of knowledge and are grounded on inferences to a more abstract way of thinking. So that matter, this is a more sophisticated way to explain what metaphors, the way metaphors work. So, for example, from our experience, we understand the meaning of up and down. So human experience is based on up and down, but then look at the way we normally use this metaphor of up and down with happy or good or more or alive or very intelligent or a discussion. So when we say we need to be more higher or add more higher components or more or overcome a situation, we are talking about going up. In contrast, down is normally associated with sad, bad, less, dead, not very intelligent discussion, with failures. And in contrast, you see, emotions are considered down because when we have, let's say, an academic discussion that becomes too emotional, we say, oh, the discussion was too emotional. We need to go further or try to make this discussion up or with better or higher arguments in context. So my point here is that metaphors are grounded on the real experience, but they are ways of express holistic aspects of our experience and concepts. So how can we find any relationship with the development of knowledge? Newton, 300 years ago, considered that it was a kind of a strange phenomena that the moon was expanding in the sky while the apple fell down in the earth. So he considered that something was poorly understood. So he started to consider, okay, if apples fall down, why don't we consider that also the moon is falling down, but also the earth is falling down to the moon? So maybe it's something that we need to better understand. During this discussion, Kepler had in mind that this force between bodies was related with this formula that you know. This formula is an algorithm, is a rule. So algorithm is a set of rules. So both Kepler and Newton consider that the algorithm was more or less the same. But why we all of us, we consider that the guy who really, the scientist who really understood what was going on with the universe at that time was Newton, and Kepler was close, but not exactly right, because Kepler thought that the universe was a clock. So it was a central engine moving all planets, and the central engine was at the sun. So he was trying to find this formula by using this metaphor of the clock. But Newton considered that an absolutely different type of metaphor. He was considering that maybe the universe was moving around some balancing forces. So for me, what is relevant about this story is that they both share the algorithm, but they had a different metaphor in mind. And what for me is intriguing is Newton got the right metaphor while Kepler did not. So this is a question I have. Can we have a right or wrong metaphors, where we build metaphors? That's one question. What you are seeing here is football, soccer in the U.S. What you can see here is essentially a scientist showing a group of robots that they are playing soccer. Okay, so so he's explaining that this group of robots can in the future bet world championships, and then you are going to see right now the robots passing the ball. I know this is very European, but you can see these are robots passing ball, and then okay. In fact, my talk started with a study I'm doing with FC Barcelona, soccer football club team. And the problem that you don't have this slide because there are some commercial logos here I don't want to share, but there are some commercial logos here that they are trying to find the way we can build algorithms to explain the way football players play football or play soccer. I'm using football as soccer, okay, because it is the way we use this term in Europe. So, but those systems don't work in general. So that was the start of my interest in this topic. And my interest in this topic is, algorithms are extremely sophisticated. They are fed with a lot of data, like Moneyball. Maybe you have seen the movie. But in football, they don't really work. And that's the intriguing question. So, as you know, algorithms can generate knowledge, although we may have all the rules or the connections, because maybe we can test our assumptions, maybe we can refine our assumptions, maybe we can create new stimulations, we can test the variables, we can create what we call static variables. We can move one variable with another variable. We can see a relationship between only two variables. The others stay still. When we talk about learning algorithms and cognitive systems, these get even better because you can understand phenomena. You can add deep layers. You can add more connections. You can add even some abstractions. You can even simulate using neural networks, as Victor or Domingos are suggesting, the ways the brain works. So we know that algorithms may generate knowledge by these type of stimulations. However, in football, they don't really work. Why is that? Because football is highly sophisticated, more than it seems. There are two ways to understand football. The first is you consider the two or three players that score goals, like Ronaldo or Messi, this type of players, and you may consider everyone is trying to pass the ball to these type of players, and they try to score. This is one way to understand football. This is exactly the video that you have seen. They have programmed a network of robots, everybody playing to someone called robot number 8, and then they're trying to represent this. But there are other ways of playing football, and may I talk a little bit about the Spanish national team when we won the the World Championship back in 2010. That people play the way FC Barcelona was playing from 2008 and 2012. They are playing at operational level in a very different way, because the lines on the field are flexible, are dynamic. They define different areas of in the field, areas that they call strategic areas for problem solving. Every strategic area is managed by one leader. So in the team, there is not only one player that tries to score goal. Everyone can try to score. So, but it really depends on the area of field. They can play in different roles, and they can they play in a more collaborative or distributed type of leadership. In fact, they are using at operational level the different metaphor is called the JAST. So the people in FC Barcelona say, okay, we are trying to teach our players to play as if they were playing jazz in different areas where they need to solve problems. They try also to highlight or to create capabilities called T-shape. Well, there are people, I assume that you know T-shape type of professional. So some, the players have some specialty, but they need to understand the full game, so they can play in different areas of the field, and they need to perform in every area of the field in order to play this type of game. But there is even a deeper metaphor. In fact, football and many other games today has a deep metaphor which is called the war. So the opponent is considered the enemy. We attack the enemy. We defend. We steal balls. We shoot. We destroy. We try to annihilate. We win. We try to jubilate. But in FC Barcelona, all these wars are forbidden. What they are trying to do is to play with an opponent. They try to possess the ball. They try to play with the ball. They try to or play or recover. We don't know. My English department, we don't know how to translate putar, but it should. But it's a different term. It's not a war term. They need to create new possibilities. They need to enjoy, learn, compete, win, be the best, learning all the time. That means that if we consider the other as an opponent and not an enemy, we are considered a similar position in power. So we have the respect for the opponent, so we can win being superior in terms of possession of the ball and try to win by being superior. That's the in-depth metaphor. So how metaphors work? Well, metaphors, as I started to try to explain, are a combination of different areas or domains of knowledge. So these domains of knowledge, for example, in my first example of Newton and Kepler, can be the astronomy or the way the universe works. We can have a second domain of knowledge, which is an object or artificial creation like the clock. In the case of football, we may use this war metaphor with the game. So as you can see, there are some connections there. But in the case of Kepler and Newton, why the clock and why to find balances in the universe? Because Kepler considered that it was a question of faith. He considered that God was in the sun, while Newton considered that God was distributed in the whole universe. So it was an M3 layer of knowledge called faith that played also an extremely important role in the way we understand today the way universe works. So my point here is that metaphors generate knowledge by connecting in the right way different areas of knowledge. They are a sort of imagination, but they can create knowledge if we combine these sources right. Maybe I'm going to speculate here, but I consider that normally simulations are algorithms are only framed in one area of knowledge. So the rules are more literal, are repetitive, and some in many examples are reversible. So that creates another aspects I don't have the time to consider today because I only have 5 more minutes to go. But reversibility is another aspect that we may consider. So this can be this diagram may be the difference between algorithms and metaphor. And I have created this another one, which explains that every time we think in algorithms and in metaphors, we are trying to use two types of language. The language of algorithms are based on framing a problem, explain. We define rules, we define a grammar, we define how to connect, we define the logic, and we define the dictionary of literal relations between sentences and concrete problems. The way of learning is stimulation, coding, and decoding. But in contrast, metaphors are based on the connection between different 2, 3, maybe more areas of knowledge. So the framing is different, and the source of knowledge is the way we intersect or interconnect the different frames of knowledge. We discover hidden connections here, and then as a result, of course, we can have science if we discover hidden connections. We may have art, and we may have humor. So my question here is, if any cognitive system may have humor, maybe yes, but that could be my contribution to you to consider. And my final slide, I think, in order to cover my 25 minutes, is that metaphors and algorithms are two ways of understanding language. We know that language co-evolved with the brain. We understand that language gathers representations and symbols and different from actions. What is interesting today, what for me is very interesting today, is that both metaphors and learning algorithms are based on real experiences. They are based on inductions and to infer from the real aspects of the world and the data. They are not artificial in the sense that they are based on our real experiences. But as I raised at the beginning of my talk, we may get the metaphor wrong, and frankly, that's a question for me. So, if a metaphor is coming from the imagination, what does this mean? Can we get wrong the domain of knowledge or the connections? And if we consider that language is related with brain and consciousness, how learning algorithms and metaphors are related with evolution, from actions to instructions at the beginning, actions versus objects, and the way we think about ourselves, the way we talk of ourselves, and the way consciousness is a result of evolution. That would be my presentation. So that's about it. So what do you think?
Thank you, Javier. Thank you for a provocative presentation, and thanks for saving some time for questions at the end. Audience, to unmute your phone line, if you're on the phone, press *1 to ask a question. If you're using the audio on your computer, there should be a microphone icon at the top of your screen, and you can unmute that way.
Hey, Javier, Jim Spohr here. Thanks for the presentation. Very interesting, as I knew it would be. And I put a couple of notes in the chat window some pointers to the work of Ken Forbes on analogy, and also a pointer to a very, very early AI dissertation about a system for learning the rules of baseball that I thought you might find interesting. And I'm wondering, you know, are you aware of any large data sets for for training up systems for this type of reasoning, or in your research, did you come across any of those?
The answer is no. There is a major issue here, which is there are sports that you can play with your hands. So all the sports that you can play with your hands are more suitable to predict. But the games that are played with foot or with the feet, they create per se very important area of complexity and uncertainty. So a prediction, for example, in basketball, baseball, or American football. American football is a different type of game, but basketball and baseball are fields where you can develop highly sophisticated data sets and algorithms because they are playing with the hand, and then you can do something more reliable in terms of prediction. But soccer, by definition, is extremely complex because you play with a part of your body which is very uncertain. That's an area of. But answering your question, no, I don't have this type of data. But the difficulty that we are facing with football is this one. It's play with feet and with your foot, yeah.
Thank you, Javier.
This is Martin Apple. I'm going to ask a question about strategy. When you have a set of defined rules and you're collecting tactics and watching their results, at what point does the collection of tactics become a strategy? How do you create strategy? How do you define the development of strategy?
Okay, so in here, when we define strategy, for example, in this type of sport, the strategy is based on different domains. The first is that superiority means you need to keep the ball, and then every time the opponent takes the ball, the aspect is to try to recover the ball as soon as possible. The second aspect is that, and this is another area of research, which is sport teams need to create organizations dynamically, but also needs to create disorder in the opponent. So by playing, the strategic aspect of the movement is to create order in one way, and at the same time create disorder in the opponent. In order to do so, you can build these different strategic areas for problem solving, but sometimes you don't have problem to solve because problem presuppose something defined or previous rules. In football, a problem is a luxury. Sometimes we don't have. So maybe we have areas of uncertainty where players need to tackle the situation, okay? And the third layer of the strategy is dependent on the player. There are capabilities. So there are some players that they have the capability of connect the rest of the team members. We call them super connectors. So if you imagine a long tail, there are some players in FC Barcelona, for example, there are 2 or 3. They concentrate about 60% of all the passes during a match. So super connection means that the system is moving depending on this type of people and depending on the way we create order and the way we create disorder in the other team. A very recent example of this can be seen if you are interested in a match of Spain versus Italy. It was 1 month ago, where Spain played with only 3 defenders. Let me put in that defenders, but the rest of the team, there were no forwarders. Everyone was midfield. So the situation for the opponent is, how can I defend 7 people who can play defend or attack at the same time? So you are creating an area of entropy in the other aspect, and you are disconnecting 3 players, 3 or even 4 defenders in the opponent team, because they don't know what to do, because defending against 7 or 8 players is extremely difficult. So these are the layers of strategy in this particular context. I don't know if I am answering you the question.
Fine.
Okay.
Thank you. Thank you for the questions. Thank you, Javier, for being our presenter. I'm afraid we're out of time. Thank you, audience, for attending. And again, Javier, great presentation. I will start a discussion group on LinkedIn. If there are other questions, please bring them there for Javier to answer. Thank you again, everyone. We'll see you next time.
Thank you very much.